right, for your do now today, you should be doing IXL L2, L4, L5, and L8. It's all in geometry, and it'll help you review for the test on Tuesday. Here we go, rotational symmetry. So this is the last thing that we're learning for the test. There is one question on it. You'll have no problem. So a figure has rotational figure if it can be turned 360 degrees or less. No, 180 degrees or less and look exactly the same as the original figure. So if we determine if each of these figures has rotational symmetry, you try turning your paper. So the first one, yes, you can turn it from this point to this point. So if you turn it from here to here, you should notice that it has rotational symmetry. This one, if you turn this shape around 180 degrees or less, let's see if I can do this. You'll notice that here it's not going to fall back on itself at all. So this one would not have rotational symmetry. So this is a big NO. Number 3, yes. You can see here, if I turn the shape upon itself here, I would have rotational symmetry, and here. Number 4, this is interesting. This is a triangle. It's a right triangle. So let's see, 180 degrees or less. What? Here we go. If I turn this 180 degrees, no, it will not have rotational symmetry. So this is a big old NO. Let's look at the letter S. Interesting. I think we'll make it a number 8. Let's see. If I turn 90, wow. This is a yes. It does have rotational symmetry. B. Let's see. No, it does not. If it was the number 8, it would. Interesting. Let's see if SOS, if we turn SOS upside down, will it have symmetry? And I'm wondering, check it out. That is so cool. So those are the shapes that have rotational symmetry. So which of these following have rotational symmetry and why? So we can look at this shape here. I'm going to trace it just like I did. Hopefully that'll work beautifully like it did. Here we go. And you'll notice I'm going to mark this one right here. You'll notice if I take this shape, oops, look at the whole thing, and rotate it like this, yes, it definitely has rotational symmetry. And you can rotate it several times. In fact, how many times you can rotate it is how many corners it has. So 1, 2, 3, 4, 5, 6, 7, 8. This has rotational symmetry 8 times. So if you wanted to find this angle of rotation, every time you turn it, it lands back on itself. You just take 360 and divide it by 8. That's too much math. Let's see, that's going to be 4. 4 times 8 is 32. That's 40. So it looks like a 45. All right. The second situation, I don't believe this looks like it's going to have rotational symmetry, but let's check it out and see. Flip this around. Definitely doesn't fall back on a 90. Oh, interesting. It does fall back on itself at 180 degrees. So this would have rotational symmetry.
Please pardon the interruption.
And it would be a 180 degree.
FGA members, GSA, Teams for Christ.
If you're an FGA, don't leave right now. Just because they're making an announcement, this happened a couple days ago.
FGA.
And let's check to see if this one has rotational symmetry. And if I look, that's a 90. There's a 180. No, this one's not going to fall back on itself. Okay? So this only has 2 turns. You can only turn it this way and then back on itself that way. Oops. So that's why it's at 180. And this one doesn't have rotational symmetry. All right, so why does it have rotational symmetry? Because you can turn it on itself. So a regular n/gon is like a polygon. We call this a polygon. Has lines of symmetry, and so basically you're just going to take 360 degrees and divide it by the number of sides in the polygon. I always look at the number of corners. It's the same diff. So this would be 1, 2, 3. So this would be 360 divided by 3. Which is 120. This one is 1, 2, 3, 4, 5. So this would be 360 divided by 5, which is 72. This one here has 1, 2, 3, 4, 5, 6, 7, 8. So it's 360 divided by 8. I feel like we just did this. I think it was 45 degrees. Okay, so that's what you would call run rotation. So for example, if I took this shape here and I rotated it from point 1 to point 2, this would be a 72 degree turn. And then if I rotated it again to point 3, that would be another 72 degrees. So if I went from 1 to 3, I went a total of 144 degrees. I added 72 plus 72 to get the big angle here. Well, let me put it in green. The big angle here is 140 degrees. All right, let's look at some example problems. This one says a clockwise rotation of 60 degrees. Well, first I have to see what the angle of rotation is. I'm assuming it's probably going to be 60 degrees. So let's see, there's 1, 2, 3, 4, 5, 6. So this is 360 divided by 6. Sure enough, it's a 60 degree rotation. So we're going to go from around point P. We'll map R onto, and it says clockwise. So I'm going this way. This to this. We'll map R onto S. A counterclockwise of a rotation of 60 degrees about the point P, which is the middle point, maps R onto Q. So if you go counterclockwise, you'll end up here. A clockwise rotation of 120 about Q maps, let's change this to a P. About P maps R onto, so now we're going to go 120. So this was 60. So we got to go 60 more because 60 plus 60, this whole thing is 120. So maps R onto T. And a counterclockwise of 180 about P maps V onto, so we're going to go 180. So that's 3 rotations. 60, 60, 60, that's 180. So it's going to map V onto R. The image E has a 72 rotation about X. So you want to name where E would be if it went counterclockwise. So counterclockwise is against the clock. It would be on P. Name the image for a 216 degree rotation about X. So P is going clockwise. So you need to know how many 72s are in 216. So 216 divided by 72. I gave you plenty of time to plug that into your calculator because I'm doing it myself. And that's 3. So that means that's going to be 3 rotations clockwise. So that's 1. 1 will be here. 72. 72. 72. So you'd end up on T. All right. And I think there's one more problem. It says name the image BM for a 240 degree rotation. So BM is here. And we're going 240. So first I need to see 1, 2, 3, 4, 5, 6. So that's 60. 240 would be 60 times 4 is 240. So that means I'm doing 4 rotations. So 1, up, counterclockwise, cancel that. 1, 2, 3, 4. So I'd end up at BD. I'm sorry, MD. All right, that's it for rotational symmetry. Please make sure you're working on your review, and you can watch the review video to check your answers.